Hello, I'm Jiblal Upadhyay. Today I'm going to describe about AWS service, which is AWS Glue, and one of the use case of it. So what is AWS Glue? Let me begin by a slide. So AWS Glue is mainly a serverless data integration service being developed to extract, transform, and load data called as ETL process. Because it is a serverless service, you just don't have to manage infrastructure, configure or scale or provision resources. Glue provides easy to use tools to create and follow up jobs, tasks based on the schedule or even triggers or on demand. AWS Glue provides visual and code-based interfaces to make data integration more manageable. With AWS Glue Studio, users can even visually create, run, and monitor ETL workflows with just a few clicks, okay? Next, going to the component of AWS Glue, and the main component is AWS Glue Data Catalog, which is act as a central metadata storehouse, which is by creating tables to store the metadata informations. And every table in this AWS Glue data catalog points to a single data stores, okay, from where it comes. Mostly the S3 buckets we'll be using in Amazon S3 bucket. And precisely it acts as an index to a schema, storing runtime metrics and location, which are very helpful in identifying the sources and target of ETL jobs. Next part, it has job scheduling system. This system automates and binds the ETL pipelines. The AWS Glue job scheduling system plays a very important role as it maintains the timing in the system, and the scheduler is flexible, can set up triggers based on the event and job execution. And the last part is the ETL engine, which is mainly it addresses the code generation of the ETL process. The code is automatically being presented in Python or Scala, and it is open code, allowing the users to customize the code. Okay, so these are the features. Okay, as I have gone through this part. Okay, and now I'm going to the AWS Glue terminologies. So what is being classifier? Classifiers are being, they provides information on the schemas about description of your data, what kind of file types you have, CSV, XML, JSON, etc., with different classifiers provided by AWS Glue. And it is a database. You have to create a database. So the database collects data in tables from various sources, and the tables are being arranged in separate categories that I will go through your AWS Learner Lab. And next important part is the crawler. The AWS Glue catalog is filled with the metadata using the crawler. So we have to create the different crawler for that one, and it will crawls along the data, and it will create the metadata information with the tables and the columns in it. So filling is done by pointing the crawler at a data stores in the data catalogs. So crawler can turn the semi-structured data into a relational schemes. Okay. So now coming to the different data target, data source, data stores. Mostly data source is used as input data for transformation. Mostly we'll be using here CSV file in the S3 bucket. And this transform data is being written to a data target. And one important concept called dynamic frame, so which is similar to the Apache Spark, we have data frame, right? So the limitation in Apache Spark, okay, those frame are being handled by the dynamic frame used in Glue, AWS Glue. And here each record will describe itself and undergoes advanced transformations, operations for ETL, and data cleaning. Mostly, the dynamic frame can also be converted to data frame and reversed. We can do vice versa on it. And what is script? Script is being, data is being extracted, worked upon, inserted into data target, and stored from various data sources using the your scripts like Python or Scala that Glue jobs creates. Next is a job, which is mainly ETL, extract, transform, load script, which will create a job. Time interval can be scheduled in between the job to run those assignments, and also sometimes the jobs are being run on demand. Okay, and tables contain the definition of data, and it can be in any form, a file maybe. Okay, mostly the S3 files or service like an Amazon RD Redshifts. Okay, so now coming to the AWS Glue structure. So when you go to the Glue structure, we have the data stores. Okay, from the data stores, it will crawl the data, crawler will crawl the data, and it will be deposited or kept as a metadata stores in the data catalogs. And this data catalog is being obtained from the AWS, which can be seen from the AWS Management Console that we will see in a bit. Okay, the data source, from the data source, our data source will be the S3 bucket here. That data source, while creating the ETL script, so it will extract your data, and then whatever the transformation logic you want to build upon it, the script you build upon it, the job you want to create it. Okay, so that will transform your data according to your business logics, what you want to build up. Mostly, I mean, as a data engineer or as a data scientist, you want to build a pipeline. So the ETL jobs, I mean, it will be, I mean, it's very handy to work upon, and then it will load the data into the data target. Okay. So in my case, I'll be using the data source as S3 bucket as one of the input folder, and the target, I'll be specifying target as output folder in one of the bucket I create. Okay. Next, how does AWS Glue works? Mostly AWS Glue carry out ETL jobs by building data warehouse and data lakes and obtain the desired output streams. If you can look here, what were the data stores? So Amazon S3, Amazon RDS, Amazon Redshift, Amazon DynamoDB, JDBC, those are the data stores, but I'm using only the Amazon S3, and we can use the connect to do those to data stores so that we can connect it to the crawler. Crawler will run through the folders of the data, and it will specify the information tables, build up your columns, and then it will write those metadata, okay, of whatever you have your data source that into a data catalogs, which is as in a database with the tables names. So I mean, how does it work? I can say here, the first the user has to determine the data source, which is used as input to process or transformation. Data crawlers will next, and this will next analyze and extract necessary information about data source and target, and then it will classifies into determine, and then classifies data to determine the formats or maybe associated properties of the raw data, and groups data into tables or maybe partitions. And now this data is being sent and stored as a metadata repository table definitions in the your Glue data Glue catalog. And after the Glue data catalog is being completely categorized, the data will be now ETL ready. Okay, that will be ETL ready, and it will be searchable and queryable. You can have build up any query. Users can now create a script, schedule ETL jobs, or set the triggers event for the jobs to start while executing those tasks. Okay, the scripts will extract your data from data source, transform, and then load it to the data target. Hence, the ETL process will be completed. Now, for my case, right now, I'm building a use case here. So I have 4 data sources. Okay, so credit card transaction, credit card, customer, and then shop. So all these are the schemas I have given out layout here. PNF are the primary and the foreign key, and those are the different schemas here. So these are in the CSV format. I'll put this in your S3 buckets. And S3 I'll use as a storage, use Athena for analysis and validation of data, whatever data you have from S3 bucket, okay, in your CSV form is being tabulated by the crawlers, get in our repository, central repository data catalogs, and then we'll use AWS Glue for PySpark ETL jobs. We'll build up for that one. So what I prepared the 4 data with 4 tables, create folders like input, scripts, and output inside S3 bucket. My bucket, I already created my bucket 902, and I need to upload all the input your folders in it. Okay, so these are the prerequisites as I have gone through this one. So I'm not going to go. So now we have to create a database in Glue with name as credit card database. So before going here, let me go to the now console, AWS console. So now this is my AWS Learner Lab. So I went to the AWS console. So AWS management consoles. Now we have AWS Glue, S3, Athena, CloudWatch, etc. So I'm using the AWS Glue here. So let me click on this part. So here in the AWS Glue, so you look on the left panel, right? Those ETL jobs, okay, that you can have to have a Visual ETL notebooks, job. I mean, many jobs you can monitor, hundreds of jobs you can monitor. Those data catalogs tables will be put it here, and you can have different connections, workflow orchestration. But I'll not go through the details of these things. And you have data catalogs which have database tables, and even the stream. I mean, stream schema registry can be done here. There can be connection we can build up, and the classifiers will be built on the crawlers, and different catalog setting we can perform. Okay, and then we have data integration and ETLs, so which is AWS Glue Studio jobs. This part I'll go through just in a minute, and there are different features that you can explore. And there are triggers, the jobs you can able to triggers in a certain schedule time, like 24 hours or something like that. Now I want to land on the legacy pages. Okay, though now recently the AWS Glue has been built on the legacy pages, and most of the workflow are being here. So just like connections, job legacy, workflow, blueprint. So first I want to go through the jobs legacy here. Yeah, in the job legacy, if you put it out, so now first thing is your databases. So you need to put the database. So before handing over here, so I have given in my slides those how I can create, I mean how I can just before one you can look here. So I can create a database like credit card database. Okay, so all my buckets, I have input scripts and input scripts and outputs. So let me show that part, and then I will come here. So this is my S3 bucket. So my bucket 902, I have already built it up due to the time constraint. I'm not showing how it is being built. It's being obvious. So I build up 3 folders: input, output, and scripts. My scripts will be here, and the output, whatever output I want, will be here in the output folder. And input folder where I'm putting my all the 4 data source. Okay, so like I build up the 4 of the folders: credit card, customer, shop, and transaction for my use case. And in the credit card, you look here, I put my credit card CSV. So similarly, you can go back and you can see in the customer, I have put it my customer CSV file. So same thing I have done for all the 4 folders. Okay, so now after this, I want to come to the next point for the use case. Okay, now I want to create the that in the database in Glue Console credit card database. So you look here. So this is the region where in the I have clicked on the. Sorry, let me go through this one. So yes, when I click on the databases, I already build up. You can add database here. Okay, so any database you can create here. So I already built up 3 of the database. One is the default and credit card database here. So this is a database. I already built it up here, and you can edit the database and tables in the credit card database. So I already build up the crawler tables like crawler transactions. I build up crawler shop, crawler customers, crawler credit card. Okay, that I'm not gonna go in more detail here. So if you go back, then this is the database I already created up. Now, if you go after the database, if you go to the tables, right? So in the tables, after your database is being created, so what is your table? A table is a metadata definition that represents your data, including schemas. A table can be used as source or target, a job definition. Now here you can add I mean, I already have those created out, but just I want to have a glimpse of how we can do it. So we can add tables by using a crawler, by you can do manually, or you can add tables by existing schema. So I have done by using the add tables using a crawler. Okay, so just in a simple form, just like I can show you testing, suppose, or maybe customer 6 plural. This was I can set it up. So all these steps, your data stores, you need to connect with the source type, and it need to crawl all folders. Next step, you need to go through and choose the data stores. Our data store right now is S3, but as I said, DynamoDB, JDBC, Amazon document, this all we can do. Now specific in my account, include your path. So I can include a path like you look here, my bucket, I can give the input as an input one. That's how I can select here, right? Then next step, add another data stores, not right now. The next, then you have to give your IAM role. So I have already existing one IAM role, so which is your lab role I have given. So next step, that's how, and I want this run on only demand. Okay, because I don't want continuously jobs to schedule because it will cost me more. So next step, and then you can database, you can choose a database. So I suppose I choose a credit card database, I already build it up. Then this is optional, then you can look here next. Then that's how we have built it up, then we will finish. Okay, so that's how we'll build the different your just like I build the customer 6 color. Okay, so I have already built the color, so this will help. And I want to see when the color tables are being built, I want to verify it with the help of Athena. So if you look here, so all the 4 just like your color credit card, color customers, color shop, color transaction, all the your tables built up is now we can verify with the help of preview tables with Athena here. Now look here, your table name and your column names all are being here. The data is being populated from your data catalogs. Okay, so that's how it grows the data. So that's how similarly you can do for next one, pivot tables. Okay, so that's how we have first name, last name, gender. So this is for your customer color. Previous one was the color, credit card, and then I have done for the color shop, and I have done for the color transition. That's how we can verify from the Athena serverless your data, whatever created, whatever data you put in the S3 bucket that has been crawled by the color. You create a table with the color, and then you verified here validation here. Okay, now next part that I want to go is about the jobs. So this is the things I already point out. Now, table with color, how you can create table with color, all this step I have shown here. So you can do the manual editions. I'm not going to go through detail. Now, next, I want to go through the ETL jobs. Okay, how we can create the ETL jobs. Similar to the color, we can do the ETL jobs. These are the steps. But the 3 ETL jobs I have performed here, but I'll just show for the one of the job. So what I'm going to do for my use case, I'm trying to find some of transaction values, okay, and group by the state for the credit card transaction I have. Okay, so this is the steps I'm going to follow here. So let me, I'm not going to detail here. So let me go to our AWS console. So in the job, you look here. Yeah, so this is Explorer. So if you look here, your jobs, so you can add a job here. Okay, but I want to show that whatever the jobs I have already created out, I think it's not showing, it's not showing me the, let me go through from here, whatever jobs I have already done. So these are the steps, yeah, so these are the different jobs I have already created out. It's like customer job, transaction to jobs, transaction jobs, testing to different jobs I have created out. So this is the page from where you can create the jobs. So ETL jobs, so I want to do the Spark script editor. So then you can just create, then you can give a name. Okay, so right now you look here, the AWS Glue is already given some of your file. Whatever that is Glue, yeah, the PySpark context need to be triggers. Okay, AWS Glue context need to be start, and this will give you some of the script here. But based on this, you can build up your own script. Okay, so I'm not gonna go to details on this part. Let me go to the one of the jobs I have. So I have created a jobs, and as I said, in my jobs output location, I have given my jobs. You look here, the 3 jobs, just like use case 1 transaction, use case 2 transaction, use case 3 customers. Okay, so these are the 3 jobs I have given. So this is the first job. You can look here, and if you, yeah, so these are the jobs I already have. This is scripts. Okay, so if you want to run here, then you can take the actions here. Then I think this was already being done. Okay, so this is the output one we have done. So use case 1. Now this job, let me go back. So this is the steps I followed to create my jobs. Okay, just like your IAM role, lab role, and you put your scripts in your glue bucket scripts, and this is the process. And now the next step, I went to show my jobs. Okay, and then my all the glue jobs I output in my output folder. So as like use case transaction those, right? And then if you go to the one of them, and let me open from here, you can see jobs. Yeah, so let me go to the glue jobs output here. So these are the different jobs I have performed, okay, on different dates. So this is the my recent one. This is 0406. Okay. So these are the jobs I have scheduled it from different timing. So the log streams that you can see, and this is the output here just for one of the job here. So this is the job profiles. Okay, these are your job logs, and then you have the this output I have for transactions value, customer's ID, first name, last name. So this is was the use case. So I have output the transaction value, customer ID, first name, last name, gender. Okay, so this I have already given here in my slide. So these are the three use case one output I have. Okay, this is the location of your jobs. This is use case 2, 1, and use case 3, 1. Okay, so that's how it works. And at the end, the significant benefit of AWS Glue are is cost effective, less hassles, proper scheduling of jobs, serverless, REST, kind of visibility of your data, pay as per users, and automatic ETL functioning. So it's very much helpful for, while building your pipeline for data engineers mostly, and for the data scientists. Okay, thank you. Stop recording.